Hello and welcome. This is now question 8 for the Edexcel C3, this gold level 4 business paper. Okay, so we're told that the differential of cos x is sin x. In other words, d cos x over dx equals negative sin x. Now don't be put off by the fact it's given in this formula. It's basically just the examiners being lazy, not saying let y equal cos x, okay, and find dy dx, okay. They mean exactly the same thing, okay, these two and the one below. So don't be put off by that, but really you should know that anyway, so it's pretty pointless them telling you that, okay. But obviously they're not telling it you just to refresh your memory and make sure you know a bit of maths. Obviously, as general with these things, it's going to relate to the next part of the question. Okay, so we're asked to prove that the differential of sec x, okay, in other words, 1 over cos x, is sec x tan x. Now there's a couple of ways that you can go about this. The given answers that, or the model answers that I checked with my answers, they did it as the bracket rule, okay. They said, okay, well sec x is 1 over cos x, okay. And they said, oh, well, therefore that means cos x is to the -1, and then he differentiated that, okay? Which is fair enough, there's nothing wrong with that, it gets you the right answer, obviously. But the way I do it is that it's a lot more easy to understand, and a lot less tricky, okay? Well, it may not mean less tricky, but it's more obvious. It's one of the things that you think you would do. Now, when you've got a fraction to differentiate, which is obviously what this is, what you would naturally want to do is go, okay, well, what rules have we got in differentiation in C3 that allow us to differentiate a fraction? Well, the only rules that we've got is obviously the bracket rule, which obviously ain't going to apply because, well, there's nothing in a bracket there. Well, obviously, as I said, you could use a bracket rule, that's another alternative, but that's not the obvious one. You might not see that straight away, is what I'm trying to say. Obviously, the product rule, well, it requires two products, what clearly isn't. And the only other rule that we have left for differentiating is the quotient rule, think of its name. Now, as I said, you could just look at a formula for that and say, well, this is in the formula, but it's actually to show that, so obviously it won't be that easy. No, it's the last question on the paper, for God's sake. Anyway, okay, so how would we categorise this? Well, normally, when we say, using the quotient rule, y is equal to u over v, so therefore you would, applying this to the current case, you would say u is 1 and v is equal to cos x. Now, don't be put off by the fact when you differentiate u, you get 0. You go, oh, no, that can't be right, because generally whenever we see a 0 to differentiate it, or to integrate it, that must be wrong. Well, it isn't, okay? There's nothing wrong with the maths we've done there, so that isn't wrong. There's no other rules that we've not considered, okay? And obviously v dash, well, we're told what the differential of cos is, so obviously, clearly, they want us to differentiate cos, okay? They wouldn't have told us what the differential of cos is if they didn't want us to use it. And the link with cos and sec is that sec is 1 over cos, or 1 over sec is cos. It doesn't really matter. So they wouldn't have told us that, as I said, without being relevant. So I think this is probably the way they want you to go about it. So v dash is negative sin x. Okay? So following the standard rule, now, as I said, it's up to you whether you actually write this next bit or not. Now, generally, what I do when I'm writing the quotient rule, to always correspond and check what I'm doing is right, I write down what the quotient rule actually is. Okay, so dy dx is equal to v u dash take take uv dashed. Okay, and that's all over v squared. All right, just apply what we've got here, okay, to obviously correspond with the quotient rule. So if you were to do that, obviously, it'd be quite easy. Dy dx is equal to, well, it's equal to v times u dashed, okay, so it's equal to cos x times 0, in other words, just 0, but you'd want to write cos x times 0 in anyway, just to prove that you're following it, okay, not just being lazy, forgetting about one of the terms. Alright, and then it's u, which is just 1, times v dash, which is negative sin x. Okay, it's all over v squared. V being cos, so v squared is therefore quite clearly cos squared x. Alright, so what we want to do now is sort of simplify this. Well, obviously cos x times 0 is quite clearly going to end up being 0. And then when you take away what this is end up going to be, negative sin x, you end up with, well, just sin x, okay? because obviously double negatives cancel. So there's a sin x on top, and obviously the cos squared x on the bottom. I'm not going to change that just yet. Obviously we're going to do that in a minute, but just for that stage, there's nothing that we need to change. But obviously we need to prove that this is equal to sec x tan x. Now if you remember, sec x is 1 over cos x. There's quite clearly a cos x in there. However, it's cos squared x and it's not cos x. We want it to be cos x. So the only thing, this is where this question is a little bit tricky, is you're supposed to spot that is a fraction, but not just any fraction. It's a fraction which is in 2 halves, but it's been combined to 1. So you think of this, right, we need it to be sec x. We need sec x from somewhere in this. And we're quite clearly, if we were to split that up into one straight fraction, okay, it'd be sec squared x times sin x, which is not what it wants. And we also need to make this equal to tan x, so it's sec x tan x. Now, if you were to write down somewhere else on your page what sec x tan x actually is, and then relate it to what you've got so far, because I think this is all quite easily understandable, okay, that might be another way to view this. So sec x, as you said, is 1 over cos x. Now, obviously, we know we're not going to get tan x from that without doing something else. Okay, so tan x we know is sin x over cos x. Okay, so that is really just what it tells you in the answer. And if we times them two together, because sec x tan x is the same as 1 over cos x times sin x over cos x. If we multiply them together, what we'll end up getting is sin x over cos squared x, top times top, bottom times bottom. Okay, so really what we do is the opposite of this. We split this up into 2 individual fractions. So we split this up into 1 over cos x times sin x over cos x. And therefore, you can say, well, obviously, the first half of this fraction, okay, 1 over cos x, well, that clearly defaults down into sec x, and we're timesing that by sin x over cos x, in other words, tan x. But obviously, I've not been entirely thorough there. I've assumed that it's x. Oh, is it? Yeah, sorry. Yeah, that's right. I'm talking about. I thought it was in terms of y. That's where my head is at the moment. Okay, so that is the answer to part A. And obviously, you know it's right if you get the answer that it proves. It asks you to show. So show that obviously you're not getting marked for the answer. But I kind of prefer them because at least you know you've got the answer right or wrong. Okay, this next part is almost going to relate to this, okay? So I'm going to just rub this all off, but I'm going to write on the board at the top, just summarising exactly what we've just done in that question, okay? Because this next part of the question is going to relate us to be able to understand that. Okay, so what we worked out essentially was that the differential of sec x is sec x tan x. So, okay, so the differential, so dy dx, remember, assuming that y is equal to sec x, always able commonly, right? The different d of sec x over dx is equal to sec x tan x. Now, as I said, they wouldn't have asked to do that without a proper reason. Now, this next part of the question is we're asked to, given that x is equal to sec 2y, that's where my mind was bringing in the y's, sec 2y, okay? What we're asked to do is asked to find out the differential of dx dy in terms of y. So we're not asked to simplify it down, because obviously simplifying it down would include it trying to rearrange it in terms of x's. It just wants it in terms of y's. Okay, so what we've got here is kind of the opposite. Well, it is this principle, but instead of y in terms of x, we've got x in terms of y. So therefore, all we can do, obviously, it's only asking us to work out dx dy, it's not asking us to work out dy dx. Okay, so dx dy, well, just assume this said y is equal to 2 sec x. What you would do is differentiate sec. So you would differentiate the term and times it by the differential of the trig function. In other words, it's a differential of 2y times the differential of sec 2y. Sorry, into differential of sec. Now we said the differential of sec was sec x tan x. Okay, so in other words, it's 2, because obviously that's the differential of 2y, times sec. Okay, and the differential of sec is sec tan. But obviously where we've got x here, we need to input 2y. So it's 2 times sec 2y tan 2y. In other words, it's 2 sec 2y tan 2y. Okay? So that is all in terms of y, and that's all it wants it in terms of, because it doesn't want it in terms of anything else. And I know that seems ridiculously short, and it is worth, well, it's only worth 2 marks, so it's not going to be that difficult. Now this next part is a little bit more difficult. We're asked to find dy dx in terms of x, okay? So that's dx dy, so we're going to be moving on from this. Now you quite clearly know that one of the dx dy is dy dx, okay? So we're going to do that as the first thing. Now obviously you might do that afterwards, but it doesn't really matter, because the principle you're going to be following is exactly the same. Okay. So we want it just in terms of x. Alright? Now quite clearly, there's one term that we can easily change to x. We know x is equal to sec 2y. That hasn't changed. Well, they haven't told us it's changed, so we assume it hasn't changed. Okay? So if x is equal to sec 2y, we've quite clearly got sec 2y here. So we just put input x where we see sec 2y. Obviously this is going to be a bit more to it in a minute. So it's 2x tan 2y. Well, we still need to get the tan 2y rid of. Now, what equation links sec and tan? Well, there's not one that links directly sec and tan, okay? There's one that links sec squared tan, so sec squared x or sec squared 2y and tan 2y. Tan squared 2y, sorry. So that in this identity, it's tan squared x, or in this case, tan squared 2y, plus 1 is equal to sec squared 2y or sec squared x. Okay? Now that just comes from the standard identity that we learned in C2 of cos squared x plus sine, plus sine squared x equals 1, and divide both sides by cos squared x. Okay, and obviously that gives you that equation, one cancelled down. So, as I said, what we want is an equation for tan 2y in terms of sec 2y, because we know sec 2y equals x, and that will allow us to sub it into this equation and give it just in terms of x as it requires. Okay, so obviously this is all in squared terms. Okay, so, but this is not, sorry, the first thing that I'm going to do, I've kind of jumped ahead of myself, is make this in terms of just tan. Now, given it's tan squared 2y, that's fair enough, we'll do something with that in a minute. So tan squared 2y is equal to sec squared 2y take 1. Okay, now it's as simple as square rooting both sides. So in other words, tan 2y, don't get rid of the x, and it's the square root of sec squared 2y, take 1, okay? And we know that sec 2y is equal to x, okay? So if sec 2y is equal to x, okay, therefore we just sub in x to this equation. So therefore tan 2y is the square root of x squared take 1. Now there's no point square rooting the x squared and square rooting the minus 1, because remember that's like saying, okay, well the square root of 8 squared plus 7 squared is the same as square root of 8 squared plus the square root of 7 squared, which quite clearly isn't. So that's why you can't break it up. Okay, so we know that is equal to tan 2y, so you sub it in to your given equation. So therefore the end answer is 1 over 2x times the square root, or x squared take 1, all to the power of a half. Okay? Alright, so that is the end of question 8. That's dy dx in terms of x. And they're not asked to do anything else with that. They could have quite easily said, okay, well that's the equation of the curve. We'll introduce some C1 or C2 identities, okay, to work out a given equation of a curve, the tangent to that curve, or the normal. But because probably they ran out of marks, they've not been allowed to do that. But anyway, thanks for watching. Hopefully it wouldn't make too much of a mess of question 8, as I did my other questions, but I'll probably come back to them and have another stab at doing them. Okay, so thanks for watching. I know it's not been an official Edexcel question, I've probably done these questions before, but whatever you're going to do. Okay, so thanks for watching. Hopefully, as I said, you've been able to manage through it, and any questions you have on anything that we've done in this paper, or again if you can't find the papers online because I haven't posted the description, or you don't know what the hell a physics and maths tutor website is, please do let me know, and I will try and guide you through it with the powers of YouTube comments. Okay, so thanks for watching. Hopefully we'll see you in the next video.